All right, we're still in Chapter 7, Methods. Last time we demonstrated using reference parameters and default parameters. We did them, of course, before we hit them in the PowerPoint, because that's always fun. But that's why when we see them in the PowerPoint, we've already seen them. So public and private, if you've taken a Java programming course or a C++ programming course, you're already familiar with those ideas. Something that is private can only be accessed within that class. Something that's public can be accessed by the other code, other classes. So if we were going to demonstrate that, we would need to make a separate class. So far, we may as well put it in the same namespace though, rather than create a brand new file. So I'm going to go ahead and make a project. I believe we're on Lecture O. Make it a console app. Alrighty. So what I'm going to do is I'm going to make a class called Circle. It's going to have a member called Radius, but I'm not going to allow our code to change that value directly. Instead, you're going to have to call setRadius and getRadius. Then we'll learn how to turn it into a property. So that you do not, well, anyways. So let's make a class called Radius. Excuse me, Circle. Private int, or why not double, radius. Now since it's private, our code down here cannot change it. So after I make a circle, circle space C1 equals new circle, I cannot call C1 dot radius and change it. One way to fix that is to add getters and setters. Another way to fix that is to turn it into a property. Once I've turned it into a property, then we would access it with a capital R. But it's certainly not a property yet. So let's add a setter for it. Oh, bless you. Now if I make this private, this is dumb, set radius double space radius, and then here we're going to set this dot radius equal to radius. This is a mutator, also known as a setter. Takes this variable, copies it in to fill in this instance variable right here. However, I mistakenly made it private. So down in here, when I try to call set radius, it's not going to work. C1 dot set radius. Well, see, the pop-up's not even giving me any hints. All right, so that's an error because it's inaccessible due to its protection level. This method cannot be called from the client code because it is declared as private. So we will declare it as public. And that fixed it. If you've taken Java programming, you're real familiar with that syntax, or C++. And we're going to provide a getter for it. I'm going to show you something. I'm going to go and look over somebody's shoulder and make sure that this works for you as well. But if I say double R equals C1.getRadius, that method does not exist yet. And so it's going to underline it with an error. And if I click around on it long enough, it gives me a little option right here. Options to generate a method stub. And if I click that, it goes ahead and creates a method for it. Potentially a time saver. Now why did it type internal double get radius? I don't remember what internal does. I'd have to look up the documentation for it. But this throw new not implemented exception. It's just to force us to actually go and implement it. So we would need to return space this dot radius here. What does that internal do? Let's run and find out. See if that works. I don't remember internal being declared. Well, it ran, right? Let's highlight that and hit F1 to see if it'll display some help on it. Internal. It's an access modifier for types and type members. Internal types are accessible only within files in the same assembly. Okay, so that's the same thing as the package declaration inside Java. It means any file that's declared within the assembly can access it. So it's public to every file that's in that assembly. But if you went and made another one, it would not be. That's confusing the issue, and I'm going to make that a public. So let me pause and see if that worked for anybody else. All right, I don't even need that line. There's nothing wrong with it. I guess I could leave it here. But now we have a getter and a setter for it, and we could write a method that would use it, right? We could write a get area, or a get circumference, get diameter, that kind of thing. Why not? Just to complete our example. Public double get area, parentheses in parentheses, and we're going to return, it's pi r squared. So how do we get pi? Math dot pi times radius times radius. Good enough. Now we have a complete class. We haven't even called that method. Down here we could, right? Double A equals C1 dot get area. There. Now we could test it out, but whatever. I need to add my read line or read key down here at the bottom just so it won't always. So, not console dot read line. I could print them out or whatever, but you've seen this kind of code before. If we made any of these private, we would not be able to call them from down here. Your general rule of thumb is your data should be private, your methods should be public. That's called data encapsulation. The reason you do that is you can modify your setters to do some data validation to make sure that this is a good value. Like say that we've decided that no circle can have a negative radius. Well, we could check that. We could do if radius is less than 0, then we could print an error message and maybe set the radius equal to 0 or leave it unchanged, right? So why not? So this dot, let's check it. If parentheses radius equals, nope, if radius is less than 0 in parentheses, then it's a problem. CW tab set radius value cannot be negative. Something like that. Excuse me for breaking it up like this, but that way it gets it all on one line. You do not have to break it up like that. And if that happens, then we do not want to set the radius to that. So we might want to stick this inside of an else. Or we just might want to return right there. Nothing wrong with doing that. You can put all of your error checking code up here, return out of it as soon as you find a problem, and that saves you from having to add additional logic structures like else's and things like that down here. So quite common, you'll see a coding paradigm where you check for like 4 or 5, 6 different errors at the top of a method. Each one of them returning something, maybe returning an area code, maybe returning nothing at all, you know, throwing an exception instead, and then down at the bottom, you do something useful. Okay, so now we have validated the data. Let's initialize our radius to 0, so I'm going to add equals 0 here, although honestly it defaults to that anyways. maybe 1 to make it a little bit more interesting. And so, no matter what, nothing ever changes this radius to a value below 0. Because the only thing that can change the radius is our setter, our mutator. Oh, and by the way, get radius is what's known as an accessor. So I'm going to add that there. It's an accessor, which is known as a getter, and the mutator is known as a setter. Now the next thing the PowerPoint ought to show is creating properties. We'll see if that's the case. I do not recall. Yeah. Okay, so here we are. Pause if you need to see the circle class, or at least the top of it, all the way down to get radius. And we didn't do anything useful with our circle once we created it. We could ask the user for the radius, we could print it out. Why not print it out? Or we could create a method that would display information about the circle. That might be more fun. I'm going to add a method to my circle class. First, let's add a comment here. End circle class. And it's just going to be called print. So public void print, parentheses in parentheses. CW tab, circle radius equals placeholder 0, area equals placeholder 1, end quote, comma, radius, or get radius, comma, get area. Remove that semicolon that you just saw me type between the two parentheses. Now, an important concept of object-oriented programming is that you do not create variables that should be calculated every time. When I figured out I was going to add a getArea function, people start thinking, oh, well, you know, if getRadius needed a radius variable, then getArea needs an area variable. And that's not true. Area should always be calculated because it's based on the radius. So if you have something that is based on a calculation from something else, that something should not be defined as a variable, because otherwise you can wind up with what's known as stale data or dirty data. Because if you set the radius, then the area will no longer be accurate, right? So that's why instead, since area is calculated from a variable, we do not define area as a variable. Instead, we define a getter for it and use that exclusively from within or without the class. So down here, after I've created my circle and set its radius, I just need to call print. Or I could have printed that information out right there, right? Already had both of those things, but why not just call c1.print here? c1.print. Or print R and A from above code. Now I don't know what the radius of something 19 is, so I'm going to change that to a 10 and then run it, because I can recognize that. Yep, that looks right. Oh, there is internal. Okay, so private means it's only available in the class. Protected means it's available to that class and any child classes, derived classes, when you start doing inheritance. Internal means that assemblies or projects that contain this class can access it, but nobody else can. And then public means anybody can get a hold of it. So you can declare a method to be static or non-static. Methods are non-static by default. They're also known as class methods in some textbooks. You refer to it without using the name of the object. Instead, you refer to the class. So for example, what if we wanted something that would count the number of circles we created? Well, that count needs to be what you might think of as a global variable if you're doing C++ programming. It needs to be something that's outside of the circle class. Actually, you could define it inside, but what do I mean by outside? Because you don't even have to have any circles created to find out what the count is. If you've never created one, if you've never instantiated a circle, the count should be 0. If you've created 3 and then released them all, then it should display 3. So that is a static variable. A static variable is one that does not exist within any particular object. It's not tied to the object, it's tied to the class itself. So let's make it public first, and then we may add a constructor and a getter and something like that. But just for now, public space static space int space count equals 0. Now this variable is effectively shared by every object of this type. Or you could think of it as it exists outside of all the objects, which is how I would think about it. Instead, it's tied to this class. So down here, if we want to set the count to something, which we wouldn't, but we're just kind of proving a point here, we could set it even before we've created any objects. Right? We could do circle space count equals 0 semicolon, right? And it lets us do that. Even though we don't have any instances, we don't have any objects, we're allowed to access it. Why? Because it's static. Now, most likely I would make that private, and that's not going to work, right? But right now, since it's public, it does work. So what do I want count to do? I want it to increase each time we create a new circle, so that if we try to print out the counter the first time, it equals 0. If we tried to print it out the second time, it would equal 1, and so on. So we're going to have to add a constructor. We need to add a constructor just so that we can have this variable incremented each time we create a new circle. So a constructor is a method that has the same name as the class itself. So public space circle, and it doesn't make sense to have a static constructor. Parentheses, in parentheses, open curly brace, and all it does is count plus plus semicolon, or this dot count, so plus plus if you like using the this reference. Nope, can't use this dot. This refers to all the variables that are inside this class, but that's only instance variables, not class variables like count. So you do not use this dot in order to reference a static variable. So that was my mistake. And we need a getter for count. We should not make it a public variable that can be changed, right? The main program should not be able to say, oh, by the way, you created 10 circles without actually having created 10 circles. We don't even need a setter because the main code should not be able to change the count. You should only be able to get it. So it needs to be static so that you don't have to have a specific object in order to find out the count. You might want to call count without having any objects created, in which case it would return 0, right? So down here, public space static space int space get count, parentheses in parentheses, open curly brace, return this dot count, semicolon, close curly brace. And again, I made the same mistake. I use the this reference so often that I did it by habit, but you cannot use this to refer to static variables, so get rid of that. And lastly, this needs to be private now. So change that to private because we have a getter, and that's the only way to access this variable. So change that top line to private static int. Now really, I like all of my variables to be declared up at the top of the class. So I should move my radius declaration up there as well. So I'm just going to highlight that, cut it, paste it right here. I'm going to add a comment that this is a constructor. And I'm going to add a comment of what a constructor is. The constructor is a method with the same name as the class, which is called when an instance of the class is created by the new keyword. And you certainly don't have to make the getter all in one line. That's a habit I have. In a little while, we're going to see using a property rather than using getters and setters. And what is property? A property is something that looks like it has a getter and setter when you're looking at the source code for the class. If count had been created as a property, then when we wanted to print the counter out down here in main, we just access it with a capital C. We would not use parentheses and in parentheses. You would not have to call get count or set count in order to do it. I'm going to delete that line. But am going to access how many circles have been created so far. Then I better pause, make sure everybody here is doing okay. So int space num underscore circles equals, and if I do c1.get count, notice it's not even offering me that option. Some languages will let you do that, get a hold of static variables by using an object name. Not this one. This one wants us to use a class name, and it's because it's a static variable which is tied to the class and not any specific object. It exists outside of that space. In effect, every object returns the same count. So circle.getCount, parentheses in parentheses. You know, and then we could print it out if we needed to know. Right now it's just going to be 1, right? We could create a new circle just to see if it winds up being 2. So above that, why not? Circle C2 equals new circle with a capital C. And now, when we're done, num circles should equal 2. And I'm going to prove that point by setting a breakpoint here, starting the debugger, wait for it to get there, hover over num circles. Ooh, and it equals 0. I wonder why that is. Oh, because it hasn't actually executed that line yet, right? And until it executes this line, we don't have a value for num circles. So I'm going to step over that line, just click step over, and there, now num circles is 2, which is accurate. Stop the debugger. All right, I'm going to scroll back up here so you can take another peek, and then I'm going to pause the recorder. This is the stuff that we added, except for the radius. All we did is copy and paste that, cut it and paste it, and move it there. Now, an important thing to remember about objects and object references, it's not specifically mentioned in this chapter, but if we set one class equal to the value of the other, C1 equals C2, semicolon. Now we have 2 names pointing to the same variable. This circle is now lost. It's been orphaned. Nobody's pointing to it anymore. So the garbage collector's got to come and clean it up. There's no way we're going to be able to find out, you know, access this circle of radius 10 anymore. And so if we did something like this, if we got the radius of C1 now, R is equal to C1.getRadius, parentheses in parentheses now, this is actually returning the radius of C2, which I think has a default value of 1. No longer is it going to be 10, it's going to be 2, because we have 2 objects, 2 references, pointing to the same object, just like you have 2 street signs pointing to the same street. Doesn't matter which street sign you follow to get to that street. Or I have 2 names, Professor Thompson and Jeff. Both of those references are the same people. If you go and kick Jeff in the knee, then you've also kicked Professor Thompson in the knee. They both point to the same person. I don't even know if I need to leave these comments here. R will return the radius of the object associated with C1. Nah, I'm just going to delete all that. Sorry. Just remember that. So every method has a return type, except the constructor. If a method does not return a value, you declare it as void. Void means I'm not returning anything. Constructors are not declared as void, they just don't have a return type at all. A method's return type is known succinctly as its type. So a method name has to be a legal identifier, meaning it can't start with a number and it can't have any spaces in it. You can pass parameters to methods. That's what the last lecture was about. Just like our radius here. If you need to pass data into a method like that, that method better be declared to accept a parameter variable, or just shorter, a parameter. So 10 is the argument that fills in the parameter variable up here in our setter. The contents within the parentheses are known as a parameter list. So if we had a function that was defined like this, foo int x comma int y comma int z, this is the parameter list. Placing a method in a class. It just goes inside the class keyword. The order in which these are defined are not important, unlike C++ or Python. So it's okay to define them in any order you want. You want to put show welcome underneath main, no problem. So variables and constants can be declared inside a method, or they can be declared in a class. If I create a variable that's part of this class down here, the one that contains main, right? Like, I don't know what it's going to be, int x. That's a instance variable. It's not a local variable. Every method inside program could be able to modify it. Similarly, up here, radius and count. These are not local variables, they're parts of the class. One is a static member, the other is not. So this is an instance member since it's not declared as static. So this variable is accessible by every method. If you've done C++ and you wanted to call it a global variable, no, it's not, but it's close. It's accessible by every function, which is the wrong term to call it, every method inside that specific class. So it's a class member, it's an instance variable. Let's put that. Accessible to every method, non-static, every non-static method in the class. Why do I say non-static? Because if this was declared as static, then it could only be accessed by static classes. Excuse me, static methods. Main would be able to get a hold of it, right? Because main is declared as static. But up here, none of our methods except get count were declared as static. So if radius had been declared as static, then these guys would not be able to access it unless they were also changed to static. Static classes can only access other static methods can only access static members of the same class. Or you can put a variable inside a method. Y, int y. Y is a local variable, accessible only inside the main method. If you write any other methods in program, it's not going to be able to get a hold of the value of y unless you pass it in as an argument, because it's local. It's like it's something inside your house. No neighbor can come and get a hold of your TV if it's declared inside your house. Let's say break in, take it. If they were going to break in and take it, I don't even know what kind of metaphor that would be, so forget that. So the scope of a variable is the area in which the variable is known. This variable's scope is from here to the bottom of the method. That's its lifetime. Once the method is left, the y variable disappears. Nothing ever refers to it again. And we have lots of other local variables here. C1 is a local variable, R is a local variable, A is a local variable, C2, num circles, all of these are local variables because they're all defined within a method. So you can declare variables, you can declare constants in a method. Well, that's what we've been doing since day one, so I'm not going to really talk about it anymore. Right? Every time we wanted to store kilograms or pounds or age or whatever, we created a local variable. So if you're going to write a method that requires a single argument, just like homework 13, you have to have the type of the parameter and a name for the parameter. And it's essentially a local variable. So if I add a method up here, whatever it's going to do, it's going to print a value, print int, void is its return type, print, but I better make it static if I want to be able to call it and test it from main. So static space void space print int, and it's going to accept a variable. I'm just going to call it print. It's going to accept an integer. This I is effectively a local variable defined within this method. It's a parameter variable, but its scope is from here to here. Nobody else can access it. And then we can print out I, whatever purposes. CW tab tab I. I is a parameter variable. It is local to this method. When we call it, we call the value we're passing in an argument. So if I print 100, it's an argument. Or you can call them these two terms instead. You can call it a formal parameter and an actual parameter. This is what's known as a formal parameter. This is what's known as an actual parameter. I don't like using the term parameter in both of my definitions, so I prefer using argument and parameter, which most textbooks do. And they even mention that an actual parameter is the argument. So let's just go down here and add a comment. 100 is the argument, which the book calls actual parameter. And so I is the parameter. The book calls it a formal parameter. So here's their method, display sales tax. It accepts a variable. Your homework is to write kilogram to pounds, so it needed to accept a variable called kilograms. It would not have been declared as void, though, because it needed to return something. So the method can accept multiple arguments rather than just one. Say we wanted to print x and y, right? Let's write another method called print that takes two values. Static void print, parentheses I, comma, parentheses j. Or int I, comma, int j. And it's going to console.writeLine I plus a quote space quote plus a j. And then when I invoke it down here, I'm going to pass in two actual parameters, otherwise known as arguments. 200, comma, 300. So you can pass in, you can declare a parameter list of multiple variables. We did that last lecture. Right? So the first time we invoked it, it called the method that accepts one int. The second time we invoked it, we passed in two arguments, so it called the other method. That's what's known as overloading. We have overloaded this function, which means to provide two methods with the same name. I call it a function, excuse me. We've overloaded this method so that one version of it accepts a single int and one version accepts two ints. And that's totally legal. Why would you want to do that? Because it makes the syntax kind of nice, right? You can call print and it doesn't matter what you pass in. We could write another version of print that accepted a string or a double or whatever we wanted. When you call a method, it will try to convert the argument type. Down here, when I called setRadius, I passed in an int, but setRadius was expecting a double. No problem, because ints convert to doubles just fine. What if it was vice versa, though? What if we tried to pass in a double to our print function? I'm going to come up here, but it's going to be an error. Right, so if I do print parentheses 1.2, 1.2 is a double because all literal floating points are doubles in this language. It's an error. Why? Because it's expecting an int, and unlike the C programming language, C++, it's not going to just merely chop this variable to fit inside an int. Like Java, it's going to complain. It's going to say that's an error. Syntax error. And the reason why is we're trying to pass in a double. They're not data types that are compatible with each other. You can store an int and a double, but not vice versa. So if we look at this error message, it says, come on, oh fine. I guess if I build it and look at the error list, it would show me the specific error. Error. The best overloaded method, I saw it briefly, has some invalid arguments. It's not a very good error. Let's go look at the error list. Okay, fine. Oh, here it is. Cannot convert from double to int. Very true. Now we could cast it. We could put, int here. But if we're going to put int there, then whatever. That'll work. My comment's out of place now. I'm going to cut that comment and paste it next to the print statement. We're getting close to stopping here. Print method does not accept a double because a double cannot be auto-converted. That's not the word that the book would use, but right, auto-converted. Implicit casting is what the book would probably call it. Auto-converted to an int. So I cast it manually or explicitly, right? With a explicit cast. You're going to stop displaying those errors? Good. All right. So a method can return a value. If you define it as a return type of double, you should return a double, or something that will cleanly convert to a double. You could return an int out of something that was defined as double, but if that was the case, you may as well define it as return type int. So a return value can be something that was stored in a variable, or it could just be a value that was calculated and returned right then and there. And we saw both examples of that. In our code, getArea, way up here, just returned a value, right? It didn't store it in a temporary variable. On the other hand, getRadius is returning a variable. Works either way, it's just fine. But once you declare a return type, there better not be a way out of that function that does not return anything. So if I had some kind of if statement for getRadius, it would still have to return some value. But since this is declared as void, the return statement doesn't have to. And it better not return any value. Now notice I have a return here, but I don't have a return here. Like a great many programming languages, if it's declared as type void, you don't have to return anything, and then it will implicitly expect that return statement to be there. And some editors will even say, you don't need a return statement here. Would you like to delete it? Okay. So you only have to have a return statement if you're returning a value or if you're returning early from the function. Because if it gets to the closing curly brace for that function, for that method, and it hasn't had a return statement yet, it just adds one implicitly to it. So calc pay accepts two variables and returns the product of them. I've already had you write a method in homework 13 that expects a variable and transforms it, returns it, so I don't see why we need to do anything new here. Methods can return a value that is of type bool. Well, of course they can, because methods can return variables of any type. It's not a news flash that this is a possible return type as well. So if is preferred customer, then return something, right? No, that's stupid. That's not a bool. We're going to write a function that's a bool. Then we're going to stop. So way down here, we had some variable called x, which was accessible to every non-static method in the class. We could do bool space is underscore x underscore 0, parentheses in parentheses, and we could just do if space x, or if parentheses x equals 0, return false, semicolon, else return true. Or you could boil that down into one line. We could have just done this, return parentheses x equals 0. Those 4 lines of code do the exact same thing as this, right? Because this would evaluate the expression. That expression returns a true or false, and then we could return that right then and there on the spot. Now, all of this stuff we can't call from main because this is a static variable, and that's okay. What do I mean by that's okay? We're just not going to demonstrate it. If I wanted to demonstrate it, I would change these to static and then move them down to main. Access it in main. I think that's enough. Let's see what's coming up. Analyzing a built-in method, passing arrays. Okay, passing arrays, that's an important topic. Alternate ways to write a main header. Sure. Writing a main method with a return type. Sure. Using methods in GUI programs. Well, you can use a method in a GUI program just like you can a console app. Appreciating scope in a GUI program. Yeah, that's worth talking about. Okay, so we really have one useful topic here and then another that's very minor. Passing an array to a method. Once you get clever, you can write something that will accept an array of variables in such a way that you could pass in one variable or 2 or 3 or 4. But this syntax would have specifically let you declare an array and then pass it in.